So, I'm, well, not on this one. So, for this one, to simplify, what you need to do is you need to distribute. So, we're going to have 3x squared plus 6x. Be careful right here. You have this minus right here. So, that has to be distributed to everything. Multiply these together first, then distribute that negative. Okay? So, we've got 3x times 2x is 6x squared. We got a plus 6x and a minus 8x, so that'll give us a minus 2x in the middle, and then a minus 8 right there. So I'm just, distributing to multiply those together. Also, whenever you're doing the derivative, make sure you put parentheses around everything, because if you're writing this without a parentheses, you're going to do it wrong there, and it's technically incorrect. I would not multiply the bottom together. I would leave it like this. Most of the time, they do not expand that. And so we would need to distribute that negative. We got 3x squared plus 6x minus 6x squared plus 2x plus 8. And if we combine our like terms, we're going to get negative 3x squared plus 8x plus 8 over x squared plus 2x squared. Now, I might, if the top will factor, you would want to factor. I don't think that will factor. So if the top will factor, you would want to factor that to see if it'll cancel with anything in the denominator. I don't think it will. I can check real quick with my calculator so I don't have to sit here and waste time. Yep. You can't factor that other than pulling negative out. So, now, I might not should show you this, but I'm going to get your calculator out real quick. In no way, shape, or form are these usually ever calculator active problems, but the back of the book doesn't give you the answers for everything. Now, sometimes the calculator does different stuff than the back of the book will. You can take a derivative on these calculators. You do, like, on the homework, I expect you to do these by hand. But if you want to check it with the calculator, you may. So if you want to take a derivative on the calculator, you are going to hit F3, which is calculate, and it's the first one, differentiate. And you will type in your equation that you have there. So you will have, for this one, make sure you put the numerator and denominator in parentheses. So you got 3x minus 4 divided by x to the second plus 2x. Yeah, so it's under F3, which is calculate, or calculus, and then you'll go, just that first one is differentiate. You're going to type in your equation, but you have to tell it what variable you are taking the derivative with respect to. Right now, that's always going to be the main variable in the problem, which is just the x for us here. So you got to put comma, x, close your parentheses. There, so that's a little hard to see. So, and the comma is next to your division key. So you will hit enter. It will take the derivative for you. Now, notice they did factor the bottom out a little bit here. So the calculator doesn't always give you what maybe the back of the book may give you, or I might do. But we're getting, and they did factor out a negative there. How does this match that?
How does it make the bottom? What x
let me show you.
X squared times x equals x to the third.
Let me show you. Because sometimes this will come up. You never know what they might give you. So if we got, these two are going to be equivalent right here. So we're trying to make what we've got match this. In the numerator, that's pretty simple. They just factored out a negative, right? We got 3x squared minus 8x minus 8. In the bottom, you've got an x squared and an x here, so you could factor out an x like this, which would leave you x plus 2, but the whole thing is still squared, right? Because everything in here was being squared. So that can be written like this, x squared times x plus 2 squared. So it does match what we've got. Again, there is no standard way to leave your answer for these, so there is nothing to say that this is a better answer than this. The calculator is not like the authority on the best way to leave your answer, but it can give you a way to leave your answer for that. Because on these, whenever you do them, I want them done by hand, and I want you to try to simplify your answer, either to match what's in the back of the book, or if it is a even problem, you can do it with your calculator to see what you're supposed to get and try to get it to match. Mm-hmm. We would nothing. The difference is how they gave you the problem in the beginning. They gave you a y equals here. So you are finding the derivative of y, which means the derivative of that equation with respect to x. If they write it like this, they would not have the y equals. They just have 3x minus 4 over x squared plus 2x. The only thing that would change about what you do here is you wouldn't need to like label that anything because it's just asking you to find this derivative, so you would just like that dy dx would not be there, and then you just have a string of equal signs. So it's really at this point a way of denoting the same thing. When we get to some implicit differentiation in Unit 3, we will see kind of why we have to use this and what it means a little bit more. But right now it just means the derivative of the equation for y with respect to x. This means take the derivative of this stuff with respect to x there. So right now it's just like a notational difference. We will kind of get into that a little bit more in some later sections about when we can use dy dx a little differently. But right now it's just telling you the same thing. Good here? All right, let's try another one. All right, this one's going to be fun because it is a fraction inside of a fraction, which means if I do this problem right here like it is written right now, I have to use quotient rule twice. I have to use the quotient rule to take the derivative of this, but then when I'm taking the derivative of the 3 minus 1 over x, I'd have to use the quotient rule again. I would rather not do that. Okay, so there's a way around doing that. We don't necessarily have to do that. What could we do to f of x so we don't have a fraction inside of a fraction here? Well, there's a couple things we could do.
You could multiply
We could.
You can multiply by x plus 5 on top and bottom.
Not x plus 5. I can multiply by x on top and bottom. Or I could use negative exponents. Either one will work for that. Which one?
It's like negative exponents would not work out very well because you got the negative magnitude of the fraction.
What do I usually do? Let me look at where I've done this before. Either one will work. When you get to this level of mathematical expertise, you just have so many tools to deal with this. Let me see what I did last time I saved this.
You got to start writing these down. Dude, I should start writing these down.
What's that?
I just made a bar for calculus.
Did you?
back to this bar.
I did negative exponents last time. Let's do negative exponents. You could multiply top and bottom by x right here. It would work. You'll get the same thing. 3 minus x to the negative 1 over x plus 5. So that is still f of x. It is really important on these. You need to do this on your homework as well. It's really simple. Label everything you do. Right? So this is still f of x, so I'm calling it f of x. Now I'm getting ready to take the derivative. I'm going to call it f prime of x. Everything needs to be labeled. Do not be lazy and leave that off, because if you're lazy and leave it off on your homework, you will be lazy and leave it off on the quiz or a test, and it's not much. All you got to do is write it one time, and then you can just do a string of equal signs, right? So we got low, x plus 5, times the derivative of the high. So that is going to be, what will we get?
It's 1.
X to the negative 2. Because negative 1 times negative will give us positive 1, and then we subtract 1 from our exponent. Minus high, 3 minus x to the negative 1, times the derivative of the low. What is that?
1.
It's just 1. Don't even have to write that if I don't want to. And then I've got the denominator squared. So we are going to not factor out, we're going to distribute here so we can simplify. So we will get x to the, let's see, that is x to the first power, multiplying it by x to the negative 2. So I'm doing x to the first times x to the negative 2. What does that give me? X to the negative 1. And then I'll have plus 5x to the negative 2. And then that 1 right there doesn't change anything. I do need to distribute the negative. So I'll have minus 3 plus x to the negative 1 all over x plus 5 squared. And we want to combine those like terms. So we'll get 2x to the negative 1 plus 5x to the negative 2 minus 3 over x plus 5 squared. Now, you got options of how to deal with this. You could move the x to the negative 1 and x to the negative 2 to a bottom of a fraction, but can we send it all the way to the bottom of this fraction? I cannot, because it's got plus and minus signs. So if I move these to the bottom of the fraction, it would have to look like this. Let's not write it down because I'm not going to do it this way. But it'd have to be 2 over x plus 5 over x squared minus 3 over x plus 5 squared. That's a route you can go. Then you got to get common denominators in the top and flip and multiply. Okay. There is another way that I think is easier to deal with here. So, whenever we have something like this, 2x to the third minus 8x squared, you can factor out a greatest common factor, right? So, like, you could take out a 2x squared on that, and then you get x minus 4, right? So, that's unrelated to what I'm doing here, just reminding you about greatest common factors, right? This is a thought bubble. So, I can take out a greatest common factor of this. Now, it doesn't look like I should, right? Because I don't have x's with every term, and 2, 5, and 3, there's nothing they have in common. But I still can take out a greatest common factor if I want. And when you take out a greatest common factor, what you want to do is take out the lowest exponent, okay? Which is what we did up here, but everything had a variable. The lowest exponent here is x to the negative 2, right? So I'm going to take out an x to the negative 2. When you take out x to the negative 2, what you're doing is you're dividing everything by x to the negative 2, right? Like up here, that's what was happening. I was dividing everything by 2x squared, and then just writing that out front, right? So I'm dividing everything by x to the negative 2. So I will have x to the negative 2 power will be out front. Okay, so let's stop and think about each one of these individually. I've got x to the negative 1 over x to the negative 2 is what I'm trying to do right here.
What do you divide, like exponents? Like subtract?
You do not divide, you are going to subtract. It is top minus bottom.
Yeah.
So that would be negative 1 minus negative 2. What does that give you?
1.
Positive 1. Or, if you think of it like this, like I could switch, I could put the x squared on top, this x on the bottom. One of those is going to cancel out. I get 2x, right? So, x to the 2x to the first power. Alright, I'm going to think the same thing over here for my 5x. Actually, no, I'm not, because if I got an x to the negative 2 on the bottom and an x to the negative 2 on the top, those cancel. Okay? And then I just have the plus 5. And then what's going to happen for this 3 over x to the negative 2? Not third. Do you have any x's on top? No. Just 3x squared. Because that x squared moves back up to the top. Because it had. So this is going to give me plus 3x squared over x plus 5 squared. Now, x to the negative 2 is multiplied by all this other stuff in my parentheses. It shouldn't be. Thank you. That should be a minus. Okay, so now because that x to the negative 2 is multiplied by everything, I can just move it to the bottom of this fraction. So I've got 2x plus 5 minus 3x squared all over x squared times x plus 5 squared. And there is a variety of ways that that could be left, but we've got common denominators. We got rid of negative exponents, so I feel pretty good about it. So this is going to be a skill that we are going to use quite a bit as we move along. Maybe not always, but if you have negative exponents, you can take out that lowest exponent, and what it's going to do is it's going to usually make all of your other exponents it's going to make all your exponents positive when you do that. Now, you don't have to use negative exponents here. You could have done this differently. There's so many ways a lot of these problems can be done. I'm not saying this is the way you got to do it necessarily. It's up to you guys. All right. This definitely looks like a quotient rule problem. Do I have to use the quotient rule for this one?
No.
What else could I do?
You can just do it. Do it.
What would I do with it?
Do the derivative.
You do it, Luke.
3x squared minus...
No, we cannot do derivative top and bottom. Cannot do that. But in this denominator here, I've only got one thing. So could I love connection this? Or I could move it to the top with a negative exponent and then distribute it. That's another option. But love connection on this one would give us, we've got x to the third divided by x squared minus 4x over x squared. So that would be just x to the first power minus 4 over x. But I could write that as x minus 4x to the negative 1 power. Right, this is still f of x. I have not taken the derivative. Is everybody okay there? So if I love connection this, I can now just use the power rule. What is the derivative of x? 1. What do I get for the derivative of my negative 4x to the negative 1? Positive 4 x and negative 2. There's a decent chance they're going to do 1 plus 4 over x squared and then get common denominators for that. So we would multiply by x squared on top and bottom there and get x squared plus 4 over x squared. Now, any of those, this is fine, that's fine, that's fine. Any of those are fine by themselves. It just depends on what your answer looks like. You could use quotient rule on that, and it will work. It's just going to be a lot more work for that because you're going to have a lot of simplifying that you've got to do. But you can still use quotient rule on that. You will see, I think, at least one of these on your homework where you could just use love connection. You don't have to do quotient rule on that.
But you could do the quotient rule.
You could do the quotient rule. It'll still work. Yeah. It's just you're going to have a lot of simplifying to do if you do that. But it will still work. All right. Now, our lives would not be complete if we didn't try one of these with some trig involved. So, okay. So, low, D high. All right, what's the derivative of cosine?
Negative sign.
Negative sign, but we already have a negative in front of that cosine. So it's going to be a positive sign. Minus high times derivative of low. What's the derivative of sine? Cosine. All over sine squared x. Do you actually remember it? It may
Is that
actually.
1 minus cosine something?
Actually, if it's squared, yes. 1 minus cosine squared x is sine x. So sine x times sine x is sine squared x. And then this is going to be cosine x minus cosine squared x. Now notice I just distributed that cosine that time. That negative has also got to be distributed. You can do it one step if you want. Just be careful. Don't get mixed up if you do. So I got sine squared x minus cosine x plus cosine squared x over sine squared x. They are not going to leave it this way. What are they going to do? All of my trig experts out there. Something I can replace. The sine squared x plus the cosine squared x. We can put those together, and what do they equal? 1. So they're going to make this 1 minus cosine. Oh, wait. Sine squared x. Can anybody make that reduce even further?
That would be 1 minus cosine over 1 minus cosine squared.
Okay. Nope. This is the direction we need to go.
No, it's 1. Isn't it 1 over cosine x?
Nope. I can't cancel that stuff because I got minus signs in between.
Oh.
But there's something else I can do. It wouldn't help us here because they're in the right direction. It's in the bottom. I can do something at the bottom. That would just go right back to where I was, but you could do that. Not quite. You're on the right track. 1 minus cosine x times 1 plus cosine x. That's a difference of squares. It'll factor. Now this can cancel. 1 over 1 plus cosine x. That's probably what you're going to see on like a multiple choice or back of the book. Now, we were done right here. You know, FRQ, we could have left it here. Or well, up here really even. Right here, you could have left it here on FRQ. But multiple choice, they may go as far to go all the way down to this. I like that problem.
It was not very cool.
I love it. All right. I can look and see what I got.
Well, would they not be?
We can listen to some of the other ones, but they're not as good.
Seven.
Let's see. Let me look at this because I don't know if that's what's on Canvas.